y-intercept for this one. So for y-intercept, you can think of ax squared plus bx plus c. That whichever number is on its own there is going to be your y-intercept, because basically x is 0. And if you're doing any exercise with the y-intercept, it is so easy, because watch, I get the y-intercept here by simply identifying the number that's on its own in all these problems. Now what happens is it's so easy to get the the y-intercept. If you're asked for coordinates, don't forget x is 0, y is 2. What you've got to be careful of is a question like F here. It asks you to find the y-intercept, right? So the y-intercept is the number that's on its own, the c value. So in this one here, the y-intercept is actually going to be positive 5. X is going to be 5. If you've got to write down the coordinates, you'd write down 0, 5. Sorry, the y value is going to be 5. So that's how you do the y-intercept. It's just so easy. You're just looking at the number that's on its own in all of these problems. So that's the first part done. So I can simply look at my equation here, and I can say, well, the y-intercept is the number on its own. I could write it as a set of coordinates. It's just minus 12. It depends, or you might say y equals minus 12. It depends on how the question is asked. Right, second thing then. Now I want to find the x-intercepts. Now for your x-intercepts, we've already talked about x being equal to 0. X-intercepts now, so y-intercept, x equals 0. X-intercept, y equals 0. Now if you make y equal to 0 in this one, you get x squared plus x minus 12. So all of that must equal 0. I've just basically switched this thing around backwards. And now that takes you away from quadratic graphs into quadratic equations. This is something that you've got to solve. So now you'd be thinking of solving quadratic equations. How can I do it? Well, at this stage, the only method you've got for solving quadratic equations is you've got to factorize this. Now at this stage, you should all be getting pretty good at factorizing these things just by looking at them. That's how that factorizes to give x squared plus x minus 12. Now from that, x plus 4 must equal 0, or x minus 3 must equal 0. So you've got your two solutions now. And those two solutions are your x-intercepts. So we can now say
just look which one makes sense.
The x-intercepts are 3, 0 and 4, 0. And that's me now found the x-intercepts. Now all those three pieces of information can come together, and we can actually draw a sketch of what that looks like. I'm just going to do a very rough sketch here to demonstrate for you what that means. Now all these three pieces of information should fit together. We said the y-intercept minus 12, let's say it's down about there somewhere. We've got an x, it crosses the x-axis at 3, 0, and then again at 4, 0. Now that looks a bit odd at first. Let's think, how does that all fit in? So that doesn't quite fit in, because I should go. There's the mistake I made there. That should be negative 4, 0. That's why it wasn't fitting. And now when I put that information in, let's just change it up here. Now it does fit. So the three numbers, that was a good demonstration there. You get these three numbers in this exercise, and they should all fit into the picture. So I've got a minus 4 here, I've got a 3 up here, so roughly what's happening is, think with your symmetry, this is where it's going to turn. It's going to turn here somewhere so that it's symmetrical. So it's going to look something like that. So just those three easy bits of information can give you quite a good graph. And in the next problem, we're actually going to talk about how we can use this symmetry problem, or property, as a different way of drawing them. But for just now, what's important is that you can be given an equation like this one here, and then you can simply read off the y-intercept, and then you need to solve. So the most important thing to do, to get the x-intercept, you need to solve it equals 0. That's what you're aiming for.